What if every decision you make creates a new universe? Dive into the mind-bending world of parallel realities where science meets science fiction. Imagine for a moment that our universe isn't alone. Beyond what we can see or measure, there are countless other realities, each with its own laws, history, and maybe even different versions of you. This idea, long relegated to science fiction and philosophical musings, is now a hot topic in serious scientific circles. Welcome to the concept of the multiverse, one of the most intriguing and mind-blowing hypotheses in modern physics. But why are scientists, people who deal in hard facts and testable theories, even considering other universes? The answer lies in trying to explain some of the deepest mysteries of our own cosmos. From the fine-tuning of fundamental physical constants that made life possible to the weirdness of quantum mechanics, where particles can be in multiple states at once. Classical physics, which describes the world around us, works great on a large scale. However, when we delve into the micro world of elementary particles or try to understand the scale of the entire universe, questions arise that our single universe can't always answer. The multiverse isn't just a cool metaphor, it's a serious attempt to expand our understanding of reality, offering new explanations for phenomena that seem incredible or even paradoxical within the confines of a single universe. We're not talking about magical parallel worlds, but mathematically sound models derived from the most advanced theories in physics. It's an attempt to answer the question, why is our universe the way it is? Maybe because there are countless others, each slightly or drastically different. The idea of multiple worlds isn't exactly new. Ancient philosophers and later thinkers of the Renaissance already wondered about the existence of other worlds. But the modern scientific concept of the multiverse gained momentum in the 20th century, thanks to breakthroughs in quantum physics and cosmology. These fields, studying the most fundamental aspects of reality, encountered phenomena that seemed to require explanations beyond our everyday experience, and even beyond our visible universe. So, the multiverse isn't a single theory, but rather an umbrella term encompassing several different hypotheses, each offering its own mechanism for the formation and existence of other realities. From infinite cosmic bubbles to worlds arising with every quantum choice, each of these ideas opens up astonishing possibilities. And our job as popularizers of science is to guide you through this maze of concepts, explaining the complex in simple terms so you can peek beyond the edge of familiar reality. What if every decision you make doesn't just change the future, but literally creates a new version of the universe? Are you ready to dive into a theory that claims all possible outcomes already exist in parallel worlds? Imagine a world where a cat can be both alive and dead until you look at it. Sounds crazy? Welcome to quantum mechanics, the science describing the behavior of the tiniest particles that make up all matter. It's here, in this strange and unintuitive world, that one of the most radical and fascinating ideas about parallel universes was born: the many worlds interpretation, MWI. For a long time, physicists puzzled over the so-called measurement problem. In the quantum world, particles exist in superposition. That is, they can be in all possible states at once. For example, an electron can spin clockwise and counterclockwise simultaneously. But as soon as we measure its spin, it chooses one specific state. Where do all the other possibilities go? The classical interpretation, known as the Copenhagen interpretation, claimed that the particle's wave function collapses into one specific state at the moment of measurement. But no one could explain how or why this happens. In 1957, a young Princeton University graduate student named Hugh Everett III proposed an elegant but shocking solution. What if the wave function doesn't collapse at all? What if all possible outcomes of a measurement are realized, but each in its own separate universe? This idea became known as the many worlds interpretation of quantum mechanics. The essence of MWI is simple, but its implications are staggering. Every time a quantum event occurs, whether it's the decay of a radioactive atom, a random deflection of a photon, or even, more broadly, every decision we make that affects quantum processes, the universe doesn't choose one path. Instead, it splits into many parallel realities. In one, you read this text to the end. In another, you got distracted by something else. And in a third, you never even turned on the computer. Thus, for Everett, our universe is just one of countless branches of a vast tree of reality. All possible alternative histories, all unrealized potentials exist somewhere out there in other worlds. The choice you didn't make, the option you discarded, all of this was realized in another you, in another universe. This means that there isn't one single future. Instead, there's an infinite number of futures, each unfolding in its own branch of the multiverse. This concept certainly raises many questions and is difficult to grasp intuitively. It requires us to rethink what we mean by reality and even ourselves. If there are an infinite number of copies of me making all possible decisions, which one is the real me? MWI doesn't provide simple answers, but it offers a deep and internally consistent way to explain the strangeness of the quantum world without invoking the mysterious collapse of the wave function. It shows that perhaps our reality is much richer and more complex than we're used to thinking, and that every moment we stand on the threshold of countless worlds. This will change the way you think about the multiverse. Everett's many worlds interpretation is just one of the amazing hypotheses. Get ready to learn about other, equally revolutionary models, from infinite bubbles to worlds hidden in extra dimensions. If Everett's many worlds interpretation makes us rethink every moment at the quantum level, other leading theories of the multiverse offer equally fascinating but completely different scenarios. They take us from the world of the tiniest particles to the vast expanses of cosmology, and even beyond familiar dimensions. Let's explore these alternative but no less captivating hypotheses. One of the most popular and well-supported concepts is the so-called inflationary multiverse. It stems from the theory of cosmic inflation, which explains why our universe is so large, flat, and uniform. According to this theory, immediately after the Big Bang, the universe underwent a period of exponentially rapid expansion. Eternal inflation suggests that this process hasn't stopped everywhere. Instead, inflation continues in some regions of space, while in others, it locally ends, giving rise to bubbles that become separate universes. Imagine boiling water. Each bubble that rises to the surface is potentially a new universe, and the bubbling water underneath is the infinitely expanding inflationary space. Our universe, therefore, is just one such bubble in a vast, constantly birthing cosmos. Each such bubble may have its own physical laws, its own constants, making each world unique. Next, we encounter string theory and M theory. These theories attempt to unite all the fundamental forces of nature, including gravity, by describing elementary particles not as points, but as tiny vibrating strings or membranes. For these theories to work mathematically, the existence of additional spatial dimensions is required, far more than the three we're used to. These dimensions may be rolled up to microscopic sizes, which is why we don't see them. However, according to some models, our universe is like a brane, from the word membrane, a three-dimensional surface floating in a higher multi-dimensional space called the bulk. And what if other branes are floating in this bulk? Each such brane could be a separate universe located parallel to ours, and possibly even interacting with it sometimes, for example, through gravity, which can penetrate into extra dimensions. It's as if our universe were a sheet of paper, and next to it floated another sheet, another universe. There are also concepts of cyclic or bouncing universes. In these models, our universe didn't just arise once, but is part of an endless cycle of expansion and contraction, a kind of big bounce, where each cycle gives birth to a new universe. Each such new universe may have slightly altered initial conditions, leading to different physical laws and properties. Thus, the scientific community offers a whole range of hypotheses about the multiverse, each with its own premises, its own mathematical justifications, and its own potential, albeit elusive, evidence. From infinite bubbles born from inflation to parallel branes floating in multi-dimensional space, these ideas expand the boundaries of our imagination and force us to take a fresh look at our place in the universe. Imagine turning on the TV and seeing a news report about a president you've never heard of, or your favorite character suddenly finding themselves in a world where everything went differently. Pop culture has long embraced the idea of parallel universes, turning complex science into captivating stories. The idea of parallel universes, as we've seen, is deeply rooted in modern physics. However, for most people, familiarity with this concept begins not with quantum mechanics or string theory, but with books, movies, TV shows, and video games. Pop culture has taken on the role of translator, turning complex scientific hypotheses into captivating stories that shape our perception of multiple realities. In literature, the theme of parallel worlds has existed for a long time. Back in the 19th century, Lewis Carroll, in Through the Looking Glass, played with the idea of an alternative reality, albeit a fantastical one. In the 20th century, science fiction writers such as Philip K. Dick in The Man in the High Castle, where Germany and Japan won World War II, or Roger Zelazny in The Chronicles of Amber, where the protagonist travels between infinite shadows of worlds, used this concept to explore historical alternatives, philosophical dilemmas, and limitless possibilities. These works not only entertain, but also make you think, what if? Cinema and television have picked up the baton, visualizing parallel worlds with incredible ingenuity. From classic episodes of Star Trek with the Mirror Universe, where familiar heroes turned out to be villains, to modern hits such as Stranger Things with its Upside Down, a dark, distorted reflection of our world. Movies like Everything Everywhere All at Once don't just show parallel worlds, but immerse the viewer in a kaleidoscope of infinite versions of one life, where every decision leads to a new reality. Series such as Rick and Morty use the multiverse for endless comedic and philosophical adventures, where the characters easily move between dimensions, meeting their alternative versions. These stories make the concept tangible, showing what the world might look like with different physical laws or different historical events. Comics are perhaps the most fertile genre for exploring the multiverse. The Marvel and DC Comics universes have long and actively used the idea of parallel Earths to explain different versions of their characters, story reboots, and crossovers between series. A vampire Batman, a communist Superman, a female version of Thor. All this becomes possible thanks to the concept of the multiverse, allowing authors to explore limitless variations of beloved heroes and plots without violating the canon of the main reality. Video games also offer a unique interactive experience of interacting with parallel worlds. Games like BioShock Infinite or The Legend of Zelda are often built on the idea of alternative timelines or realities, where the player's choice can lead to completely different outcomes. This allows the player to not only observe the multiverse, but also actively participate in its formation, at least within the game world. It's important to understand that pop culture, while making the idea of the multiverse accessible and fascinating, often simplifies or dramatizes scientific concepts. It plays with ideas that may be mathematically grounded, but rarely directly visualizes them as physicists imagine them. Nevertheless, it is thanks to these mirrors and reflections in art that a wide audience begins to ask questions about the nature of reality, about choice and its consequences, and of course, about whether there are other us out there in the infinite labyrinth of parallel worlds. Imagine, in an infinite multiverse, there are trillions of versions of you living every possible life. What then is the value of the single self and the uniqueness of your choice if everything has already happened somewhere else? Our journey through the multidimensional labyrinths of the multiverse inevitably leads us to the deepest questions that philosophers have been trying to answer for centuries. If parallel universes really exist, how does this affect our understanding of ourselves, our free will, and the uniqueness of our existence? Scientific hypotheses about the plurality of worlds go far beyond physics, challenging fundamental philosophical concepts. The first and perhaps most intriguing question concerns identity. If every quantum event branches the universe, creating countless copies of me who make different decisions, which of these me's is the real one? If in one reality I became an artist, in another a scientist, and in a third I was not born at all, then where is my true essence? The concept of a unique personality, which we value so much, begins to crumble under the pressure of an infinite number of alternative selves. This makes us wonder if our self is rather a function of a specific set of events and memories in this particular universe, and not some absolute, indivisible essence. The next puzzle is free will. We're used to thinking that we make conscious choices that shape our future. But if every possible decision has already been realized in some parallel universe, then how free are we really? Isn't our decision simply experiencing one of the already existing branches of reality? This idea can be perceived as a form of determinism, only not within one universe, but on the scale of the entire multiverse. If everything that could have happened happens somewhere, then our individual choice may seem less significant, if not illusory. However, on the other hand, it is in our universe that our choice has consequences, and it is here that we experience its result. And finally, the question of uniqueness and the meaning of existence. If everything that can happen happens, and everything that can be created has already been created in some other world, then doesn't our life lose its special value? Achievements, love, suffering. All this is probably repeated countless times. Doesn't this devalue our experience? Paradoxically, for many, the thought of infinite possibilities can be inspiring. It can emphasize that it is this, our life, this, our experience, these, our relationships that are unique to us in this particular reality. Each moment, each decision takes on special weight because it is our moment and our decision, even if its alternatives exist somewhere else. Thus, the multiverse is not only a scientific hypothesis, but also a powerful philosophical tool that forces us to rethink the most fundamental aspects of human existence. It offers us a look at ourselves and our world from a completely new angle, asking questions that may never have a definitive answer, but which inevitably enrich our understanding of reality. Imagine just one breakthrough and our entire reality changes. What if we're on the verge of a discovery that will forever change our understanding of the cosmos and our place in it? Let's talk about how science is looking for evidence of other universes. So we've dived into a world where reality isn't singular. But how do you prove the existence of these worlds if they are, by definition, beyond our reach? This is a grandiose challenge for modern science. Direct observation, as in science fiction, is not yet possible. Nevertheless, scientists are looking for indirect traces of their existence, relying on subtle anomalies and theoretical predictions. One of the key avenues is the study of the cosmic microwave background, CMB. This is the echo of the Big Bang, the most ancient light that permeates the entire universe. If our universe is just one of the countless bubbles in the inflationary multiverse, then perhaps we once collided with other such bubbles. These cosmic collisions could leave imprints on the CMB in the form of unusual cold or hot spots, anomalies that are inexplicable within our own universe. Some scientists are already studying such inexplicable cold spots, such as the well-known cold spot in the constellation Eridanus. Although there is no definitive evidence yet, it's like looking for bruises on the surface of a pond that may have appeared from a collision with another body of water. Another direction is the search for signs of extra dimensions predicted by string theory and M theory. If our universe is a brane floating in a larger multidimensional space, then gravity, unlike other forces, can seep into these dimensions. This may manifest as slight deviations from the law of universal gravitation at very small distances, or through unusual gravitational waves. Experiments at the Large Hadron Collider, LHC, at CERN are also trying to find evidence of extra dimensions. For example, if high-energy particles created in the collider disappear, this may mean that they have flown away into other dimensions, carrying energy with them, which manifests as missing energy in our dimensions. The possibility is also considered that dark matter or dark energy, these mysterious components of our universe, may be related to other worlds. Perhaps dark matter is particles that weakly interact with our world but are common in a neighboring Brane. Or is dark energy a manifestation of vacuum energy from another dimension? These hypotheses open up exciting possibilities. Of course, all these searches are incredibly complex and are at the forefront of science. We're working with indirect signs, with mathematical models, and with the most sensitive instruments ever created by man. The evidence can be subtle, barely perceptible, but the desire to understand what lies beyond our visible universe is too great to give up. We continue to build more powerful telescopes, conduct more accurate experiments, and develop more advanced theories. The goal of this research isn't just to confirm the existence of parallel universes for the sake of sensation. It's an attempt to answer fundamental questions about the nature of reality, about why our universe was so perfectly tuned for life, and about whether it is the only one. Perhaps one day we will discover irrefutable evidence that will forever change our understanding of the cosmos. Or perhaps we will only strengthen our thought that our universe is the only one. But understanding this path is priceless in itself. Our journey through the boundless expanses of the multiverse has come to an end, but questions about other realities remain open. If you are as passionate as we are about the mysteries of the cosmos and ready to look beyond the horizon of the familiar, subscribe to the Epoch Echoes channel. Like this video so we know you're interested in exploring the unknown with us.